Hello everyone and welcome back to our cybersecurity class. Today we are going to cover security design principles and patterns, okay? And let me say, like always, we start with our learning objectives. So by the end of this week, you should be able to explain the purpose of secure design principles. You should be able to identify core secure design principles, and also you should be able to recognize common secure and insecure design choices. So what we'll do is that we are going to start with a very simple idea that security design principles exist in order to help developers build highly secure applications. So the keyword here is design. Think of it. So these principles are all about fixing bugs after an application is built. Design means they are about thinking about security from the very beginning, how the system is being designed at that while the system is being designed or built at that time, they are, I would say, integrating or thinking the security principles. Okay, there's the word design. This is why I'm insisting on it. So throughout this lecture, what we're going to do is that you will see most serious security problems are not caused by advanced attacks, but they are caused by poor decisions made early on during the design phase. Okay, so these principles give developers a structured way to think about security before any code is written. Okay, so the first step in secure design is something called asset clarification. Before we even think about security controls, we need to ask basic question, which is mainly what data does this application handle? Not all data has the same value or the same type. So we have sensitive data, we have private data, we have personal data. Some data is public, okay? Some data is sensitive and some are, I would say, is extremely critical. So security controls should be designed based on the value of the data being protected. Like for example, let's think of an application that process financial information. Like for example, something that let's say credit card numbers or dealing with the bank details. So these kind of apps, they mainly require much higher security controls than a simple application, like for example, a simple blog, I would say, or a web forum or something like this. So if developers treat all data the same way, what will happen in this case? Think of it. Whether they will treat all the data like it's not that much important security there, okay? Like they are going in this case to under secure critical things like critical apps like these for like bank details, for example. Or the other opposite case is that they are going to treat all, I would say, the data that as if they are extremely sensitive. In this case, what will happen is that they are going to over secure. And if they will over secure, it's okay in the case of bank, but imagine they will be over securing the simple blog or the web forums. Okay, so this is the, I would say, the contradiction, and asset clarification helps us from the start to avoid both. Okay, so let's move on and discuss another key part of secure design, which is understanding attackers. It's very important that when developers design security controls, they should not assume that everyone will use the application as intended. Okay, it's very important. Sometimes we need to think, they need to think or ask who may try to misuse this system. Okay, if there are some uh, part is going to misuse the system. The question now is going to be why, okay? So in this context, we have different attackers, and different attackers have different skills, have different like motivations, they have different levels of access, okay? And we are going to discuss uh, most of them. So what we have interestingly here is that one of the most dangerous types of attackers is like dissatisfied staff members or programmers. Yes, don't get shocked, because these are the people who already understand the system, okay? They may already have legitimate access, okay? So these are extremely dangerous, okay? Next, we have like the driven by attacks, which means like here attackers are a kind of automated, okay? They have the automated tools to spread like viruses, to spread trojans through, I would say, kind of specifically targeting. It's not like they're going or specifically targeting one system, okay? They are just spreading them without any specific or particular system in mind, okay? We have next the motivated cyber criminals. They are another major threat. So their goal is usually to steal sensitive information or to also steal personal data. And their main point or objective is to make money. Okay, so at higher level, also maybe we have criminal organizations. So criminal organizations like usually or may have, I would say, resources, significant resources, and long-term malicious goals. Okay, and finally, we there are the script kiddies, and these are attackers who only rely on existing tools and scripts, often like without they don't have the fully understanding how they work. Just they are having them ready and just doing it. So the key takeaway is that security controls should be designed like with multiple attackers types in mind. So it's not just most obvious one, okay? We need to think of all these. Now, moving forward, what we have here that all security controls are designed with these three like core pillars of information security in mind. This is known as the CIA. C is for like confidentiality, I is for integrity, and the A is for availability, okay? CIA. Um, and let's call the CIA triggered. So the first pillar now here is the confidentiality. And this means that data should only be accessible to users who are authorized to see it, okay? So in practice, this involves like things like authentication, like access control, and permissions. Now, the second pillar is integrity. Integrity ensures that data is not trampled with, tempered, I mean, not deleted or not deleted, sorry, altered, means it's not modified, okay, by unauthorized users. So when integrity is compromised, the data may still be accessible, but it can no longer be trusted. Let me give you an example in this context. Suppose that I am sending you a message right now. I'm saying something for you, and you are receiving this message. It's not enough that you are just receiving my message. It's very important that you are receiving the message as it is. It's not like someone is changing my words or changing whatever I'm saying, okay? So this is very important. The third pillar now, which is also important, is the availability of the system, or availability ensures that systems and also data, we talk about data as well, are accessible to authorized users when they need them, okay? A system is, I would say, which is secure, okay? We have securities there. We are very happy it's existing, but the system is not available. So in this case, it's still considered as a failure. So what is the use of having the secure system which is not available, okay, unavailable? So every security design decision in this lecture is mainly support. It's mainly like supporting one of these, one or more of these like three pillars. Now, let's move on to security architecture, and let me just go through this slide. So every application like has application security measures, or I would say includes security measures that are mainly designed to handle wide range of risks. These risks can be simple or unintentional, like we are hiring some new developer just deleting the database. It's not a problem. No, it's a big problem, but it's done and not like it's not unintentionally. It's done unintentionally. If some we have an intern and he's making a big problem, and this is happening. So this is the first type. The second one is imagine that it's happening intentionally. Okay, it's extreme. So like for example, the example of brute force attackers or injection, sorry, attackers and so on. Okay, so these are the two possible, I would say, ways or typical uh, kind kind of risks. And now, because of this, what will happen? Security should not be added like to an application as a single feature, okay? Because once it's you're breaking that, all is gone, okay? It needs to be parts of what we call an overall architecture, and ask themselves like a few questions that we can go through right now. The first question is the process surrounding this feature as safe as possible? In other words, is this is a forward process? So the second question is, if I were evil, how would I abuse this feature? Okay, so this question mainly helps developers think like they are attackers instead of a normal user. Okay, so the third one maybe we have is the feature required uh, to be on by default. If so, are there limits or options that could help reduce the risk from this feature? Okay, so mainly these questions they help ensure that security is considered at the design level, not after problems appear. So before we dive in, I want to pause for a moment and explain how I'm going to approach these security design principles. So these principles come from the OWASP, and mainly OWASP stands for the Open Worldwide Application Security Project. Okay, so the WASP is a non-profit organization that publishes widely used guidelines and best practices for building secure applications. Okay, so mainly this is what I want you to know about this organization. And it presents 10 principles, okay, for the security design, okay. These 10 principles, just as a note, they are extremely important, okay, and they all are having, I would say, the same importance, but let's say none of these principles is not important, okay? But the way I'm going to approach this, like these principles, just like to make the content easier to follow, less overwhelming for you, we're going to split them into two parts, okay? So we are having these 10 principles. Like the first one is to minimize attack surface area. Second one, establish secure defaults. Third one, least privilege design principles. Fourth one, we have the principle of defense in depth. Next, we have fail-safe default design principle. Sixth, we have don't trust services. Seventh, we have separation of duties. Eight, we have the avoid security by obscurity. Eight, nine, sorry, keep security simple. And 10, fix security issues correctly. So to not keep it like boring or long recordings, and what I want mainly is I want to make it engaging. Okay, so in this video, just the introduction. In the next video, we are going to focus on the first like 5 principles. Okay, we are going to go through them one by one, and we focus on how to design or to design a system to be secure by default, starting, I would say, from architecture and access control and so on. In the next video, and in a separate one, we are going to cover the rest, okay? So principles from 6 to 10, okay? And these, in my opinion, mainly focus on human behavior, on system interactions, trust boundaries, on how security holds up over time in a real world system. So these are going to be in a different video to not make it boring and long. So this separation mainly is not from the OWASP, by the way. It's simply a teaching choice to help you organize these ideas more clearly as you learn them. Also, when I'm going to split the lecture into 3 parts, you will feel whenever you have 15 minutes, you have 20 minutes, you can feel happy and you feel that you did something, you completed something, okay? So just we go to the next video. Thank you for watching.